Okay. So for this session, we will start with beam example. This is indeterminate beam to the first degree of indeterminacy. Okay, we have fixed at A, and roller at B. So this beam span is 12 meter, and this beam is subjected to a vertical load of 50 kilonewton at point C. So this is actual beam. So actual beam is indeterminate beam. So we are going to analyze this. We are analyzing unknown reaction. There are 4 unknown reactions. So we are going to analyze this 4 unknown reaction. So remember flexibility method. We use flexibility method whenever 3 equilibrium equation is not enough to solve for the unknown reaction. That is where flexibility method takes place. Okay, so remember the final objective or the final goal in analyzing indeterminate structure is to analyze reaction for flexibility method, to analyze reaction. And since there are more than 3 unknown reaction, and we know that only 3 can be solved using equilibrium equation, so we have to have another equation, okay, to solve for the unknown. Okay, so by looking at this diagram, so we find that there are 4 unknown reaction, 1, 2, 3, and 4. 4 unknown reaction. Okay, we have AY, AX, and MA, as well as BY. Okay, so the first step, we need to identify number of redundant. Number of redundant can be determined, okay, by finding the difference between total unknown reaction and 3 reaction that can be solved using equilibrium equation. Okay. Degree of indeterminacy, okay, is equal to total unknown reaction. There are 4 unknown reaction. 4 unknown reaction. Okay. 4 unknown reaction, degree of indeterminacy equal to 4 minus 3. Okay, 4 minus 3. 4 is unknown reaction. 3 is referring to 3 reaction that can be solved using equilibrium equation. So we get 1. So this 1, okay, 1 represent number of redundant in the system, and redundant is to remove. We need to remove redundant in order to determine redundant. Okay, remember the final objective is the 3 unknown reaction. We have to calculate 4 unknown reaction. So between these 4, we have to divide into 3 and 1. We have to divide between 3 and 1. So because these 3 can be solved using equilibrium equation, 1 cannot. So the problem is this, 1 redundant. So we have to determine the redundant first, then only we can solve the remaining reaction, 3 remaining reaction. Okay, without redundant value, we cannot solve the 3 remaining reaction. And this redundant will be solved using what we call as compatibility equation. So for those who have not yet watched the recording last week, please watch that video, because the the concept introduction about the compatibility equation I have discussed in the video last week in the class recording. Okay, so we have to identify redundant. We have to identify redundant, and always remember redundant will be removed from indeterminate beam. Means that if we remove one from redundant, it will become 3. Okay, so we need to remove. So when actual beam, after we remove one from one support, after we remove one support from actual beam, the beam will become determinate beam. Determinate beam, and we have to make sure that we get either cantilever beam or simply supported beam after removing redundant from the system. Okay, so after we identify number of a number of redundant, we have to choose redundant. So we have to choose redundant. So let's say we choose BY as the redundant in the beam. Okay, choose BY as the redundant in the beam. Okay, choose BY. So means that we will determine BY. We will determine BY, and BY will be determined by using compatibility equation. BY will be determined using compatibility equation. I have discussed what is actually compatibility equation, and I have shown in the previous class how we derive the compatibility equation, which is actually based on the principle of superposition. We will mark, okay, the displacement occur at redundant position, and from that, from principle of superposition, we write the compatibility equation. Okay, please refer back to the video. Okay, for BY as redundant, for BY as the redundant, we will write the compatibility equation. Okay, the compatibility equation, since B is force, BY is force, P, it is P. Okay, recall back to what you have learned previously. Okay, under unit load method, when you want to calculate delta, you will apply a unit force, P, a unit force, and BY is P. Okay, when we want to calculate rotation, we will apply a unit moment. Theta, we apply a unit moment. Okay, delta, we apply a unit force, and BY is force. BY is P. BY is P. So always remember, this is the partner actually. P and delta, M and theta. This is the partner. Means that if the redundant is force, either it is vertical force or horizontal force. Okay, representing by BY in this case, okay, means that we have to look at the displacement occur at position B, at the redundant position. BY is redundant, the position of the redundant is B, means that we have to look at the delta that is occur at each diagram. Each diagram means we will have 3 diagrams. Based on the principle of superposition, we will have 3 diagrams. Okay, so we will write the compatibility equation based on that one. Okay, compatibility equation we get from general equation, which is based on the principle of superposition. This is from principle of superposition. And from the general equation, actual structure equal to primary structure. You can find this in the notes as well, plus redundant structure. Okay, so to solve for the redundant, we have to apply what we call as principle of superposition. And in principle of superposition, we have what we call as general equation. So what is general equation? It is actual structure equal to primary structure plus redundant structure. Actual structure is indeterminate structure. Primary and redundant structure are both determinate structure. Okay, so from this, we will write the compatibility equation, which is based on the displacement occur and these three structure, three beams, three systems. Okay, so compatibility equation equal to, okay, it is delta, delta B naught, By. Since the position is B, it is equal to delta B naught. Okay, we will write the equation. Start from the primary structure because the delta in actual structure is equivalent to 0. This is delta B naught plus with FBB. F is displacement due to a unit value of By. Okay, times with By times with the redundant. And this is actually equal to delta B, actual beam. This is actual beam, delta B. But in actual beam, delta B is equal to 0 because of the support. This is actual beam. Okay, since we have decided By is the redundant. Okay, By, we have chose By. Here, By. So the deflection, we have to look at the B position. And in actual beam, there is roller here and there is no deflection because of the support. So delta B is equal to 0. Delta B is equal to 0. Okay, primary beam. Primary beam means we have cantilever beam. After removing redundant, it become cantilever beam. Cantilever beam, no, this is B, no roller support. We have removed the roller. It is now become cantilever beam. So we actually need to identify this delta at position B for primary beam. This is primary beam. Okay, so these are all that I have discussed in the previous lecture. Okay, delta B naught. And in order to analyze this question, actually, we don't need to draw the deflection again. Okay, the deflection that I have shown to you is just to show how we get the compatibility equation. Okay, so this is the primary system. This is 6 meter, 50. Okay, 50 kilonewton, 50 kilonewton. This is A and C. Okay, so delta B naught. Delta B naught means vertical deflection at position B for primary beam. The first notation for the position, the second notation for type of beam. Naught is always symbol for primary beam. Okay, FBB. FBB is deflection due to a unit value of redundant. Deflection due to a unit value of redundant. Okay, the same type of beam, if primary is, the primary beam is cantilever beam, the redundant also cantilever beam. It is a cantilever beam subjected to a unit value. Dekat mana a unit value tu? Dekat B. Okay, a unit value of by. We have removed by. So by is equal to 1 times by. By is equal to 1 times by. Now we are going to analyze a system, a determinate beam, a cantilever beam subjected to a unit value. So we have to remain A, C, B. Okay, so these are the two primary two cantilever, two determinate beams. Okay, both are determinate, so we plus this, we get back to actual beam. Okay, plus this, we plus this, the first, this one is primary structure. Okay, this is redundant structure. Due to a unit value times by, we have to remove by. Okay, so the cantilever beam is subjected to a unit value of by. So actually FBB is this one. Delta, it is deflection due to a unit value of by. We call it as FBB. FBB. But in analysis, we don't need to show where is the position. The position is we draw the position when we are asked to derive, okay, from the principle of superposition. Okay, so these are the two determinate structure, determinate beam. One is a primary beam, which is a cantilever beam subjected to external loading 50 kilonewton located at C. And second one is the determinate beam, cantilever beam subjected to a unit value at B. Okay, so compatibility equation we will write based on the displacement that is located at position B, at redundant position. Okay, so in primary beam, we have what we call as delta B naught, and in redundant beam we have delta, we have vertical displacement we call as FBB. That is why we get delta B naught plus FBB times By. We get equal to 0. We get equal to 0. So we don't write actual 0 equal to delta B naught plus FBB times By, but we write start from primary beam, delta B naught plus FBB times By equal to 0. So that is how we get this equation. So actually, whenever you want to analyze structure using flexibility method, the first thing to do is identify DOI, because DOI representing number of redundant in the system. Choose redundant. We have to choose redundant. We have two options. We can also choose to remove MA from the system. Okay, and if MA is the redundant, so we have to look at the rotation at A. So this time, since BY is redundant, it is located at B. That is why we have to look at the delta at position B. And from principle of superposition, we write compatibility equation directly. Because this is just the standard form of compatibility equation. Delta B naught plus FBB times By is equal to 0 is actually the standard form of compatibility equation. And this one will change according to the redundant position. For example, if C is the redundant, so it will become delta C naught plus FCC times CY. If D is the redundant, it will become delta B naught plus FDD times DY. If MA is the redundant, so we will change to theta A naught plus FAA times MA is equal to 0. Okay, so now we focus on this first. Okay, what is delta B naught? What is FBB? Okay, since this is the value that we are going to determine, the redundant. So in order to get the redundant, we have to have delta B naught and FBB value. And delta B naught and FBB value is the two displacement that is located in primary. We identify that this is the primary system because of the naught symbol, delta B naught, and FBB is the displacement in redundant system due to a unit value. We know that this is displacement because F is actually the symbol for redundant system. Displacement in redundant system, we use label F. Okay, this is the standard form. Okay, what is delta B dot FBB? For beam and frame, we integrate to determine to calculate the delta. Okay, to calculate the delta, it is just like the formula we use to calculate displacement using unit load method. Whenever we want to calculate delta, we have to integrate two moment equation. Whenever we want to calculate delta. Theta also same. We have to integrate two moment equation. Okay, if we want to, we will use this equation as well to calculate, to analyze thrust. But in thrust, the member forces, the internal forces in thrust is come from member force. So we have to find N, not M. Okay, so what is delta B naught? So we apply formula that we have used previously in during last semester. Okay, the formula to calculate delta, we have to have two moment equation. This is delta B naught. So what is the formula for delta B naught? We have to have 1 over EI due to bending effect in beam and frame. We have to include EI, and then we integrate two moment equation. We have to integrate two moment equation. This is M, this is also M. Remember, to calculate displacement, we must integrate two moment equation. Okay, from 0 to L, this is the same formula that you used previously under topic deflection in CES521. Okay, so we have M what? M something times M something. Okay, so what is this two? Okay, it is actually refers to the notation that we use here. The notation, it is refers to notation that we use. This notation, B and naught, we have B and we have naught. So we will have MB and M naught. MB and M naught. So what is MB? What is M naught? Okay, what is MB? What is M naught? M naught is always labeled for primary system. Okay, MB refers to redundant system. Okay, so we have the second formula. Okay, for FBB. For FBB, okay, this FBB. Okay, what is FBB? FBB is displacement due to a unit value of BY of redundant. So same formula, but we have to change two moment equation. Okay, the two moment equation, we have to change to MB, MB. MB, MB. And MB is the moment equation in redundant system. Okay, so these two MB can be written like this. Okay, wait. Two moment equation M. This is B. Wait, I want to copy from yesterday. Okay, so this is the two formula for displacement. Displacement. So this is what I always remind last week. So we have to start with always look at the top. Okay, the backward calculation. Backward calculation. Okay, on top we have to calculate three unknown reaction. Three unknown reaction. And actually we have four, but we have to divide into 3 and 1. 3 is unknown reaction. Remaining unknown reaction. Unknown reaction. Okay, just like as reaction here. Okay, and 1 is redundant. 1 is redundant. Okay, so how to solve this redundant? How to solve this redundant? How to solve this redundant is by using, okay, by using what we call as compatibility equation. What is inside the compatibility equation? What is inside the compatibility equation? There are two displacements. There are two displacements come from two systems. One is primary system, one is redundant system. Okay, so what is the formula to calculate displacement? So the formula, inside the formula, we have to have moment equation. MB and M naught. There are two moment equation. This is also MB. Okay, so from where we know that this is MB and M naught, we get from the notation that we use. MB, the delta B naught is MB M naught. FBB is MB, MB or MB square. Okay, so what is MB, what is M naught? MB, MB what is MB? MB is the moment equation in primary. So sorry, what is M in redundant? So this is in redundant. Not is primary. In redundant system. It is MB because B is the position of redundant. In redundant system. And we have M naught. We have M naught here. Is the moment equation in primary system. Okay. So we have, from this, we know that we have to have two equations. We have to have two, not two equations, two systems to be analyzed, and both systems are determinate system. Okay, what are the system? What are the system? This is the system. Okay, yang atas ni. This one is the system. One is primary system, one is redundant system. So we have to write the moment equation in both systems. Means that we have to do the same in both systems. Okay, we have to do the same in both systems. So we have cantilever. We have cantilever subjected to 50 kilonewton. Okay, 50 kilonewton. This is 50 kilonewton. Okay, so this is also 50 kilonewton. So this is 6 meter, 6 meter. So this is cantilever. So what is the moment value for this moment? 50 kan tadi? Okay, 50. Okay, MA state moment at A is equal to 0. So this is MA. MA plus 50 times 6 times 3 equal to 0. Yang ni dah pakai negatif, so put negative. So MA is equal to 50 times 6 times 3.
900.
900. So this is 900.
Doktor,
Ya?
kenapa kena dengan 3?
Oh, betul juga tak ada 3. 5 kali 300 je lah kan?
Ya.
Betul. Bagus. It is 300. Not 900. Okay. So 300. So ni dah dapat reaction in primary system. Okay. Reaction in primary system. Okay. Lepas tu for the redundant system. For the redundant system we have okay, this one is redundant system. This is redundant. Okay, for redundant system, we have cantilever beam subjected to a unit value of redundant. So this will become -1. Balik. Satu lagi, moment. So what is the moment value?
12.
Okay, so this is 12, this is 1. Okay, remain, so this is 2 determinate beam, A, C, and B. A, C, and B. So we will have 2 sections. Because we are doing this because we know that we will continue to write moment equation after this, right? Okay, so from primary system, we get M naught. From redundant system, we get MB. So we have to cut section. Okay, same section for both. Okay, same section. If primary system has 2 sections, redundant system must follow. Okay, so next is, because what we want is moment equation to be the input in the equation. So next is the moment equation. So since we have more than one cutting section, so normally we summarize in the table form. Okay, so in the table we have member, and when we write moment equation, we have origin as well as limit. Okay, limit from A to C, from C to B, limit. Okay, and we have one column for M naught and we have one column for MB. Okay, one column for M naught and one column for MB. Okay, and another one for MB. So one for primary, one for redundant. Okay. We have 2 cutting section, AC, and CB. And CB. Okay, for AC origin, we choose A as origin. For CB, we choose B as origin. Okay, always choose the shortest cutting section. Always choose the shortest cutting section, so A and B. So limit will be A to C is 6 meter from 0 to 6. And for CB, okay, it is also from 0 to 6. Yang ni, okay, if you don't understand, please refresh back. Okay, yang ni you dah belajar since in apa? Solid mechanic. Okay, you have learned this in solid mechanic. Please refresh. Okay, M naught. M naught is the moment equation for section AC. So what is the equation? What is the equation? What is the equation? What is the equation? Moment equation. What is moment equation for AC origin A? AC origin A. So the moment is acting like this and like this depending on the origin. Depending on the origin. So both will be the same. So sinilah dia punya M naught and inilah dia punya M B. Okay. So M naught is 50x. It is 50x minus 300. Okay. And CB equal to 0. MB is 12. It is 12 minus x and x. And x. Please check. Okay, so this is the moment equation we get from primary system and redundant system. So this is primary system, this is redundant system. So what we need to do after this, we substitute this into the formula. Substitute into the formula. Okay, we substitute into the formula. Okay, actually you don't need to rewrite the equation. Anyway, this is the first time, so I just write the equation because this is the first time. So next time, just use the equation in the table and substitute into calculator. Do not need to integrate manually. Okay, just use your calculator. MB, this is MB. MB. And M naught. M naught dx. Okay, we have to plus with plus 1 over EI, 1 over EI, 0 to 6, it is 0 and X. Sini 0, sini X. Tak tulis pun tak apalah, 0 and X ni we get 0. Okay. 0 and X actually we get 0. Okay. So what is the answer? What is the answer? What is the answer? Please calculate using calculator. What is the answer?
$9,000
9,000. It is 9,000
over EI.
over, yes, over EI. Over EI. Okay. Okay, next. FBB. Next is FBB. Okay. From 0 to L to 6. It is 12 minus X. Twelve minus X square. Okay, 12 minus X square. Kejap, tak masuk. 12 minus X. X square dx. So plus it is X, right? X square dx. So what is the answer?
576 per EI.
576. 9,000 tadi negative 9,000 or positive 9,000?
Negative.
Yeah?
Negative.
Negative. Negative 9,000. Okay, now we get this. Okay, the displacement in redundant system, and this one is displacement in primary system. Okay, what we need to do, we have to substitute into the compatibility equation. Okay, so substitute. Okay, substitute delta B naught and FBB into the compatibility equation. Okay, into the compatibility equation. Actually, the compatibility equation that you wrote, okay, after you decide, after you have decided the redundant, will guide you from the first process until the end of the process. Because from this, we know that this is M naught, MB, M naught, MB, MB. So we integrate to get the displacement. So this will guide actually, will guide us actually. Okay, this one is 9,000 kat mana tu? One this. Boleh, tulis lah. Awal lah. Jadi, boleh lah. Okay. So instead question again, it is negative. It is 9,000 divided by EI. Okay, it is negative. Plus with 576 divided by EI. Okay. Redundant, we must always times back whatever value, displacement reaction from redundant system. Remember, we have always need to times back with the redundant. Times back with redundant. So that is why we have this times with BY. Okay, times with BY. Okay, equal to 0. So this is the compatibility equation. So solve the compatibility equation. Solve the compatibility equation. So what do you get? BY equal to 9,000 divided by 576 equal to BY equal to
15.625.
15.625.
625.
625 kilo Newton. Okay? 625. Then you can continue. To calculate remaining reaction using equilibrium equation. Can you do that? Can you continue to calculate remaining 3 unknown reaction?
Can.
Yes.
Okay. So this is actually flexibility method. And this is how we analyze beam to calculate redundant. And after redundant is determined, we will continue to calculate remaining reaction using equilibrium equation. Okay?
Okay.
Clear kan?
Boleh.
Okay. So thank you very much. InsyaAllah we will meet again. Saya akan buat satu replacement class this weekend insyaAllah untuk kita cover derivation compatibility equation for 2 redundant. So that next week we focus on example only, first redundant, single redundant as well as double redundant. And we cover all beam, frame and truss. Okay, so thank you very much. We close a session today with Tasbih Kifarah and Surah Wal-As.